plus sign is the same as and. No. So it's 3 of this and 2 of that. So for our first one, we have inside parentheses, we have NH4. How many N's do we draw? 1 right there. And how many H's? 4. And now we draw that whole thing again because it was in parentheses with a 2 outside of it. And then how many S's do I draw right here if I'm ignoring this coefficient? 1. And now because the coefficient said 3, I draw the same thing, so I have it drawn 3 times total. So I draw it 2 more times. I need it a 3rd time. And I need 2 O2s. So one O2 looks like this, and second O2 looks like that. So when I count up my totals, I've drawn 6 N's, 24 hydrogens, 3 sulfurs, and 4 oxygens. Are there any questions before we take our homework quiz? Okay, so the homework quiz is going to require you to draw like 2 pictures or work with 2 different molecules. And then there'll be a question. It'll be like, how many hydrogens or how many sulfurs or how many carbons or whatever. So we're going to take that quiz right now, but then stay on Zoom because we are going to then take some really important notes that we're going to need. So the quiz should be appearing in Classroom. I'm going to repeat myself so I can get that on the recording. Sorry, guys. So we're starting here with the law of conservation of mass. And basically, that tells us that we can balance an equation because it tells us the mass before a reaction is equal to the mass after a reaction. So the total number of each element before the reaction is equal to the total number after. In reactions, we make bonds and break bonds and rearrange what is bonded, but we do not create or destroy elements. They still exist before and after. And we have these really important steps for balancing equations. And if you need to pause the video if you're watching it, please do, because I'm about to make the top part of the notes disappear. But you need steps 1 through 4. So the first step says count how many atoms of each element are on each side of the arrow. And I'll show you that in just a moment. Step 2 is to put coefficients in front of compounds to balance the equation. Step 3, if an element is found in multiple compounds on the same side of the arrow, we balance it last. And step 4 is that we make sure that the coefficients are in the lowest ratio. We're going to do a couple examples today, and then we're going to call it for today. And we'll learn more. We'll do some more balancing practice together on Thursday, and then we'll do the back of the worksheet from yesterday. So that worksheet you got yesterday, keep it. We're going to use it in class on Thursday. Okay? So for our first example, we're going to do an example that happens in our atmosphere every single day. Way up high in our atmosphere, there's a whole bunch of hydrogen gas. There's also oxygen gas. And when the hydrogen gas collides with oxygen gas with enough energy, it can form water gas. That's how we get water, some of the water vapor up in our atmosphere. It forms clouds. When it gets heavy, it falls down in the form of rain. Right? Some of the water gets by evaporating, some of it literally forms up there. And so this is a reaction. And notice that I left a space in front of each compound. That is the space where we will put the coefficient if we need it. Now, ladies and gentlemen, I have been balancing equations for way longer than you have been breathing. Okay? And I've been teaching it for about as long as you've been alive. So I figured out a way that really helps people stay organized. Yes, you can do it in your head. Can I do it in my head? Absolutely. But the writing it down the way I'm about to show you is the way to guarantee that you don't make little mistakes. So practice my method. Don't skip it right away. Okay? So the arrow is what separates the reactants from the products. And the law of conservation of mass says what we have before is equal to what we have after. Jackson, will you put away your phone, please, and make sure you're doing these notes? So we're going to count how many atoms are on each side of the element, but I like to use the arrow because that's the dividing line. Whatever's on this side needs to be equal to what's on this side. So right underneath the arrow, I'm going to write the elements I see. I see hydrogen and I see oxygen. Those are the only two elements I see in this reaction. Now, we're going to count how many are on each side. How many hydrogens are on this side of the arrow? 2. How many hydrogens are on the product side of the arrow? 2. You see how I put 2 on whatever side I was looking at? How many oxygens are on the left side of the arrow? How many oxygens are on the right side of the arrow? 1. So this is a quick way of looking. Are the hydrogens balanced right now? Yeah. How about oxygen? No. So step 2 says to put coefficients in front of compounds to balance it. So the element that needs balancing right now is oxygen. And there's 2 oxygens on this side, so I need to find a way to get 2 oxygens on this side. But I'm not allowed to mess with these little subscripts. That's not allowed to change. The only thing I'm allowed to do is put coefficients in front of the compounds. So if I want another oxygen, if I want 2 oxygens, not 1, then I'm going to need 2 waters. Does everyone agree with that? Now, if I have 2 waters, how many hydrogens do I have on this side now? 4. And how many oxygens do I have now? 2. So yay, I balanced the oxygens. But in doing so, hydrogens are no longer balanced, right? Now we've got 4 hydrogens on this side, so I have to come over here and say, what number do I put here so that there's going to be 4 hydrogens on this side? A 2. So now I have 4 hydrogens on both sides, hydrogens balanced. I have 2 oxygens on both sides, oxygens balanced. This is a balanced equation. I don't have to do step 3 on this one, because step 3 is just a hint, really. And it says if like oxygen found in 2 places on the same side of the arrow, which it isn't, or if hydrogen were found on 2 places on the same side of the arrow. It's not relevant to this problem. Step 4 is always a good final step. And that's looking at your coefficients and making sure they're in the lowest possible ratio. What number is technically here that we didn't write? A 1. So can we simplify a 2, a 1, and a 2 any further? No. If we had messed up and somehow gotten our numbers too high, which happens, if we had something where it was like a 4, a 2, and a 4, could we have simplified that? Yeah, they're all divided by 2. But if you have a 1, then you know you're good and you can stop. So that is it for that problem. We're going to do one more today, and then we're just going to end. And we're going to do a little bit more notes at the start of class on Thursday, and then we will do our worksheet that we started yesterday. We'll do the back of it. So for our last example, I'm going to remember what equation I want to use. It's going to be Na plus HCl making, I have to think for a second, H2 and NaCl. And so again, I've got gaps in the front where I could put coefficients. So I need to find my arrow, and I'm going to put the elements right underneath that arrow so it can split the in front of the arrow with the after the arrow. So the elements I see are sodium, hydrogen, and chlorine. Does everyone agree? And if I see them on one side, I have to see them on the other, or it's not a correct equation. How many sodiums are on the left side of the arrow? What? I just don't hear anyone. 1. How many hydrogens are on the left side of the arrow? 1. The arrow's right here, so over here there's only 1 hydrogen. How many chlorines are on the left side of the arrow? 1. How many sodiums are on the right side of the arrow? 1. How many hydrogens on the right side of the arrow? 2. How many chlorines on the right side of the arrow? 1. So right now we need to balance hydrogen, right? It's the only element that doesn't match on both sides. There's 2 hydrogens on this side, so we have to find hydrogen over here. What number do we put here to make it so that there's 2 hydrogens? a 2. And that's awesome. It makes 2 hydrogens, but it also impacts something else. What does it impact? Chlorines. We now have 2 chlorines. So we balanced hydrogen. Now we got to get these chlorines balanced. So we hop over here to NaCl. That's where chlorine is on the right side. What number do we have to put in front of it? A 2. And that makes it so we have 2 sodiums and 2 chlorines. So now the hydrogens are balanced, the chlorines are balanced, the sodium is not. We hop over here, we put a 2 in front of the sodium, and now that's balanced. And it just so happens that every element, there's 2 on each side. So we are going to end there for today. We're going to keep going with these notes on Thursday. Tomorrow's assignment and the way to get marked present for tomorrow is to do the pH lab if you haven't done so. You guys got pH papers sent home with you, the little orange strips, and there's a little color coding, and basically you dip them in different liquids. I recommend things out of your refrigerator, things out of your bathroom or cleaning cabinet, and you're gonna get a lot of different colors that way. Maybe even try water. And so you're just writing what color you see and then looking at the kind of color coding to tell me approximately what pH it is. So that lab is tomorrow's assignment. It's also the way of getting marked present on tomorrow, okay? So I will see you guys on Thursday where we'll keep working on this.